I'm going to now give the floor to Eoghan. Over to you, Eoghan.
Thank you for having me, Derval. So yes, my name is Eoghan. I am from Dublin, Ireland. I am working on my first game called ExoDomia under the studio Fomorian Studios, what I set up with 3 guys straight out of college. So to get into it, if I can click on my slides. Yeah, okay. So a little bit of background. It's a 3-person team. It's myself, Wesley, and Adam. We all studied a animation degree in Pulse College. It was a 3-year-long BA. And coming out of that college, we kind of all decided that we wanted to get into games and move away from the animation area. However, one thing that was useful for us is with the animation degree, we learned a lot of the key aspects of asset development. So learning how to develop props, make characters, rigs, animations, all that sort of stuff, we had those skills. But unfortunately, we didn't have any coding skills coming out of that college. So we decided to pick one person to learn how to do code, and I drew the short straw. So when coming to doing the actual development process for that, we had to pick, for one, our engine and what we're going to use, which turned into Unreal Engine, because they have the blueprint system, which is a visual scripting system for writing code, which works a lot easier for me having to learn something for the first time. So what exactly do I do? So being in the kind of indie game development scene requires me to do quite a lot of different work. And I don't just mean doing a lot of work and as in putting in the hours. I mean like jumping between areas of the pipeline constantly. So for 1 week while I might spend all that time doing code. The next I might be animating or writing some music or doing some level design. So there's a huge variety of stuff that I get to work on, which keeps things really fresh. So I have a few examples here. You can see on the top right side is a system I wrote a couple of weeks back that basically does enemy relocations. So these are the main enemies that you see in our game, and they now have the ability to kind of stand up, run into another place of cover, and get back down. So it gives a much more dynamic feel to the enemies that we have. In the bottom left is a visual representation of a rig of one of the creatures we have. So I would have to go in, taking a model, give it all its bones, give it its controllers, and have that set up ready to be animated and move around. On the right side as well, then, it's just some simple, just a showcase of like player HUD. So I'd be putting in like the text information, make sure that it's not too intrusive, keeps it minimal and clear for the player to see. We're going to have a quick look at the Unreal Engine interface. I have a little drawing tool that I'm going to use. I hope this works. I just recently downloaded it. So over here on this side, if this is visible, you can see a little box where I've highlighted the viewport. So I know Unity has a viewport as well. And that's just where you can show on like how to build levels and where you place all your stuff. On the right side is the outliner.
Can I jump in there, Eoghan? Have you seen Unity before? I mean, that does look quite similar.
There's a lot of similarities you can draw between the two. Like, it is very similar. I used Unity briefly before when I was learning how to make a game ages ago, back in when I was in school. And so I am a little bit familiar with that engine, and it is very similar looking, but there's also some differences. So I don't know whether this might look vastly different to your eyes or not, but I hope it kind of makes sense from coming from on a new set of eyes. On the right side, you have your details panel, which shows your... Oh, sorry?
No, what I didn't understand, Eoghan, was what you were referring to that we might recognize from Unity on that right-hand screen. What were you saying might be similar to Unity?
Like, I assume there's some sort of outliner, which shows all of the things you've placed in the world. So that's... so you can kind of keep things organized. Down on the bottom right here, there's a details panel, so it shows all your location, rotation, and scales of individual things placed in a world. And then at the very bottom is your content browser, which shows, or where you can access all of your code, your assets, your animations to be able to be put into your game engine. So you'll be basically store all of your information in your folders like that in there.
Yes, I think Marten was going to jump in and say that's the inspector. Is that what you were going to say, Marten?
Yeah, that's what I was going to say.
Oh, that's what it's called in Unity. Okay.
Yeah, great. Keep going, Eoghan. That's
cool.
Great.
So a brief overview on the game we're making, ExoDomia. So what exactly is it? It's a first-person shooter that's a single-player game. Now, unfortunately, There's no co-op or multiplayer. We decided against going down that avenue because that's a whole lot of more complications and code that you have to deal with. So we decided to keep it just onto the single player and made within Unreal Engine 5. The core premise of the game is that you crash land down onto a robot inhabited world, and you have to fight your way to escape through environment blended levels with a wide variety of different enemy types and tons of things to explore, buildings to go into, environments to roam, new weapons to find, that sort of stuff. So I'm going to talk a little bit about C++ and blueprints, but I will admit, I assume most people in this call know way more about C++ than I do, because I use the blueprints visual scripting system for Unreal Engine. So to see here, I hope... Sorry?
I would say to that, we have had some exposure to C++ in a part of a larger course, but we haven't done much on C++. We focused over these past 3 years with C#, but we're very fascinated. We're C# with Unity, but very, very fascinated to see the blueprint system.
Yeah, so with the blueprints, it's a visual node scripting. So you basically have all these different boxes that perform different kind of commands and executions. So when I go into, I have an example on the next slide. You can see up here in the top right, these over here, these over here are what are called events. So they're these red boxes, and they basically fire off code. So like with the event begin play here, when the game starts for the first time, it will fire off code coming out of here if you have any strings attached to execute on said code. So whether it's like spawning in a player, destroying something in the world, moving something from position A to B, that'll all get fired from the beginning of the game. Another example of an event is any damage. So if something receives damage, it will then fire off code to do a set action that you require after something has received damage. And then there's also the event tick. So every tick, this is going to fire off code all the time, which can get very expensive if you put quite demanding pieces of code. So if you're spawning an actor, for instance, like an enemy into the world, and you put that on your event tick, you're probably going to get like a couple thousand of enemies spawned within like a few seconds, you know? So you want to avoid using those kind of things.
Just to explain to the team, when you say expensive,
detriment to performance.
Mean expensive?
Very detriment to performance. So it basically will cause your game to lag very much. And you want to avoid doing things that cause your game to lag, because then that's going to be very bad for the consumer, for people who are playing games. Down the bottom right is variables. So these are just housing containers for stored information. So like the first one here is called a Boolean, which is your basic simple true or false statements. So an unticked box would be false and a ticked box would be true. Down here, you've got your string for holding text information, your integers for holding whole numbers, and your floats for holding decimal numbers. On the right side, you got your vectors, which is your location, your rotators, and transform. So these handle information, like if you were to spin a character in a world, you'd use those through your rotators and your transforms. I have an example here on the next slide, kind of showing it in execution. So you can see in this little example over here, in this GIF video, you basically can click anywhere onto the canvas display, and then you type the type of node. So as you kind of develop more and more, you begin to get a library within your head of what blueprint nodes do which. So this one is just a simple event begin play. So when the game starts, I'm just going to print the hello onto the screen. And then here over on this side, this entire bit of code here is just a very simple, doesn't hold much purpose, but it's just saying on the beginning of the game, we're checking if I'm setting an integer to 0, this little box, and then we're checking if that integer over here equals 1. And since it's 0 up here, it's going to go down this chain. If it was to equal 1, it would go across onto the true chain, like so. It takes a little bit of time to kind of learn how those work, but once you kind of get it, it allows for very quick iteration. Okay, so one of the things that's very important, and this is with any kind of coding, is to comment your code and keep it very neat and tidy so that you yourself in the future, if you're looking back in maybe a month's time can understand what it is that you wrote, and it doesn't look like a completely new language to you. Because I've had times where I've learned the hard way of writing some code, coming back and not understanding at all what it is that I've just written. So keeping things commented, neatly organized is very, very important. So absolutely do organization and don't do spaghetti mess, which is what this is referred to at the bottom here when it comes to blueprints. And as well, comment on if you're using C# as well. Make sure you have those comments so you can understand what's going on.
Can you replace every form of coding by blueprints? Like, do you just...
Oh, yeah, sorry. I meant to mention that. So a lot of the debates between visual scripting and your normal coding, like C+ or C#, is what is the capability of blueprints? Can it rival? Is it worse? Is it better? Like, what is the answer there? And it gets a lot of mixed opinions. A lot of people argue that C++ is more performant, which it absolutely is, but that only really comes into play if you're working on some AAA game that needs every single bit of like a frame tick and latency for like huge multiplayer games where code needs to be as fast as it can. If you're working on some single player indie style game, it's not as important because the difference in performance is not noticeable. It's also argued that C++ is better for writing systems versus building content. We haven't had any issues as of yet in developing the systems for our game, and it runs and just fine. So it's very much dependent on the type of game, the scale of the game, and the code itself and how it's written. But it's just as functional, I've found, and just as useful. And has a ton of resources for learning online. YouTube videos explaining how to do different types of blueprint coding. So it integrates well for what we've found.
But just to continue on that point, Marten, I was discussing earlier with Eoghan, like, what does he do if there are errors in his blueprint? Like obviously with our autocomplete or with our large language model of choice, we can copy and paste the code into Claude or Gemini. Here, what do? I don't know if you can screenshot the blueprint and upload it. Maybe you want to talk to that, Eoghan.
Yeah. So I might actually have an image here. Let me have a quick look. So one of the things that you can actually do is you can I forgot to mention this when we were talking earlier, but you can actually copy and paste C++ code onto the canvas and it will convert it into blueprints. This is just a more zoomed in view of the interface for blueprints. So when we're doing we've the three people working on the game at the one time. And sometimes I need some quick code on my friend's PC build. So I can like drag select all my code, hit copy, go over to his or paste that into like a notes file, which converts it into C++, then send that notes file over to him, copy the notes, and then paste that onto the canvas, and it'll print out all the blueprints ready to go. There's some issues depending on certain blueprints or dependencies that you've got if you haven't developed them on the other end, but it generally works fairly well. We use that with our materials system.
Does that also work the other way? Can you get blueprints in and get code out? Because maybe code works better.
Yeah, so you can do that. I haven't tested it very much, so I wouldn't speak either fondly or dismissive of it. That's why you only use the blueprints, but you can absolutely get the code out of blueprints, and when you package the game all down, it converts all of the blueprints back into C++ code, so you can access and see what your code is doing. You can also make a new blueprint itself, like a little box, and then put C++ code into that so that you can basically make your own custom blueprints if you want a specific function to be done. So you basically it's kind of unlimited with what you can do, and I haven't reached any bottlenecks with capability of the engine for that, which has been quite nice. So yeah, going into the game concept for how we kind of came up with our game. One of the things that's very important when designing a game from scratch, any kind of game, is think about games that you actually enjoy, that you have fun playing. Gather some inspiration, and for areas such as the game mechanics themselves, or maybe some story, or maybe some like really nice visual that you liked before. So one of the huge inspirations for me for making the game was Call of Duty World at War, because I was a big fan of that growing up as a teenager, playing that game and playing that campaign. I really enjoyed how the enemies interacted with the world and they were moving around, and it just felt like a very immersive experience. So I drawn a lot of inspiration from that to put into the game that I'm building here. One of the important things I'll say as well is allow ideas to, like, don't get too attached to one specific idea. Allow them to change over time, because sometimes you'll find that an idea that you might have in your head in execution doesn't turn out to be as fun or works as well as you thought it might have in your head. So be okay with things not always being the way that you expect them to be. For example, we initially started when we were starting at this game initially, made a building system for the game. And through playtesting and experience, we decided ultimately to kind of can that system entirely and not use it. So we have that on a zip file somewhere. So there's an entire building mechanic system on my computer in the office, but we've just removed it from the game because the workload got too much on that end. It required too much stuff to do, that we decided to cut that and focus primarily on just the shooter and story experience of a game. And playtesting. Playtesting is the most important thing ever when it comes to any game. Get other people to play it and get them to play it without you interfering. Because one of the things that you'll always find yourself naturally doing is if a player gets stuck, you'll want to help them. You'll be like, oh no, do this, do that. But they should know how to do that themselves when they're playing the game. They should figure it out. Either the game should explain that mechanic or there should be a tutorial there. If you have to help them do or understand something, then that's a issue that you should then try and work towards resolving. So it's very good to get people from all kind of backgrounds of gaming experience to sit down with your game and see if they can actually figure it out and understand how it works. So looking into the asset pipeline for our development, all of our assets go through basically like a 5-step process to get them from their concept to the end result. They start basically where the three of us sit down and go, okay, we need a new enemy type. What is it going to be? How do we want it to work? And when we kind of loosely pseudocode write that down, we go, okay, we need an enemy into the game. So Wesley goes off and he models and designs a character. So over on this left side, you can see this is the first enemy. Oh, sorry, wrong button. On the left side is the first enemy that we have. My drawing tool is not working anymore. Our assets go through 5 stages. So after they get modeled, which we see on the left side, it gets sent over to me, and I basically review that model. I make sure that it works with its rig. So I design all the bones and to allow for the movement. I designed the controllers so that when you're animating, you can move the bones. And I make sure that there's no clipping. So if I was to lift up the character's arm and bring it up over its head, that the arm, there's no features on the arm that will collide and clip into the head. So make sure that it works as a proper character. When that's done, we send it over into Substance Painter, where we bake out our model. So you can see it doing this kind of colorful pass and then like this black and white pass, which basically bakes out all these different texture maps. You got like your roughness, your metallic, your ambient occlusions, normals, height maps, all these different things that give it that detail. And then we texture it as well to give it a color. In a software called Maya, I don't know if you have any experience with Maya or maybe Blender. Blender is very similar to Maya, is where I use for animation. So I give it like a run cycle, and then we compile all that together into Unreal Engine to give us the end result of a animated running textured character. Then when we get those characters up and running, so here's just another character example of me testing the movement and feel of the rig to make sure that it works good. So I've used what's called an IK rigging system, so that the legs stay attached to the ground while I move the hip bodies, so that all 6 legs are just like firmly placed and I can rotate them around. It leaves a very fun effect, but that's kind of just me reviewing to make sure that it works. Then I'll go in and I'll start being like, okay, so what do we want this creature to do? So I look back at that kind of pseudo code we wrote and we're like, okay, so we want our enemy to be able to stand up from cover, shoot, sit back down, maybe run around, that kind of idea. So then I have to go and kind of make a checklist of all these different animations that I have to make. And they'll be little snippet animations. One might be a second, one might be half a second, one might be 2 seconds or 5 seconds. And I build a library of all those animations, and then I bring that into Unreal Engine and start blending them all together with code, so that when the code tells an enemy to stand up, the enemy physically stands up, and then when I tell him to run away, he'll start his running animation and start running away. Or if he shoots, he'll like point at the player and start firing his gun with the animation that I built there. And at the bottom is one of the systems that kind of determines all that. So you write these behavior trees that say, okay, pick a location. This is just for basic movement here. Pick a location, set the movement speed to walking, walk over to that location, and then pause and just wait. And then repeat that process over and over and over again. So then you can get very expansive with all the systems on how you decide and design your enemies. But it's good to have all your different animations working so that the end result looks quite fun. A little bit onto level design. So with our workflow, we have broken it kind of into 6 stages. We start, because we're using the one world, a big kind of open world to explore. We pick an area that we start zoning. So Adam, the developer, does kind of some landscape zoning. So he'll go in and he'll design, sculpt some landscape, give the different feel, make sure there's enough space for what we're about to build. Then I will go in and do the first blocking pass. So we'll make sure that there's the good places to run around. There's places for the enemies to be, enemies to fight back. Oh, sorry, I just clicked that. And that you can run through it and it works. Then we play test that with some people, make sure that's good. Then I do the blocking pass plus, which is what you can kind of see here. So this is a building I did earlier this week. It's a containment facility for one of our creatures. So you basically go in, guns a-blazing, fighting the robots, and then you get into the creature that's on the inside, and you have like a mini boss battle. So I basically design the makeup of that building with a bunch of assets that we have. We've built a library of assets for building, basically like Lego blocks. So you can kind of sit there listening to a bit of music, just designing some fun things. It's like playing Minecraft as well. It's very relaxing and fun to do. And then when that phase is done, I send that over to Wesley, where he adds all the textures and does the prop detail pass, where he fills it up, makes it look like it's a lived-in kind of world, and all those extra like finishing touches to bring it all together.
You mentioned Minecraft. Really, is there similarity between building in Minecraft?
I was a big Minecraft player back when I was like a teenager and a kid, and I don't know how many hours I've gotten that game. But when it's building, I build all these to get these kind of buildings using like snapping tools and stuff. So I'll pick like 100 units, maybe a meter, and I'll use a meter, and then I'll like drag something off so that it snaps into position, almost like you're building blocks. And then you kind of do your layers of your blocks, and then you do your other design. So there's a lot of similarities and design aspects that I've actually drawn from playing Minecraft and other kind of building games. Like Satisfactory would be a big one, or like Subnautica, if anyone's played Subnautica, where there's those building mechanic games. There's a lot of similarities that I kind of use there to actually bring things together. And yeah, it's a lot of fun to do that kind of end of development. A nice break from some of the more difficult areas.
Yes.
But yeah, so one of the steps that for like building a game is obviously getting it up onto a platform for people to play. So Steam being the major PC platform out there, we wanted to get our game up onto that as a store page ready to go. So when you're doing that, it requires a lot of different processes to be completed, like basically a huge checklist, and you can see them on the left and right. There's your store presence one, and there's your game build one. So on the left side, you have to fill out stuff like your basic info, your game descriptions, system requirements, your capsule imagery. So that's basically like your advertising imagery. So the rectangular square image that says ExoDomia there, you just have to kind of produce, I think it was something like 25 individual ones, because every click needs to have a different ratio of imagery, depending on if it's viewed on a mobile or on a website, windowed viewed, if you're going on it from the store page, or seeing it as an advertisement down below. You need so many of them. And I had to do that all twice over, because I built this page and the demo page. So then I made one that says demo on it as well. So I doubled my workload on that end. But in the end, it was worth it. And I've made it so that like you can change anything at any time. It's very adaptable. And then on the right side, you have to make sure that the game is playable. So you have to send the game off to someone who works over at Steam for review. So they get the copy of your game, they play it, make sure it works, make sure it's real, make sure that it fits in with any guidelines, that kind of thing. And then come back to you and go, yep, it's good. Or, oh no, this file directory was wrong. You're going to have to change this and this. And sometimes there's a little bit of a back and forth between you and whomever you're discussing with Steam until that all gets good. And then after you do all of those tick the box steps, it's ready to go. So
when will it be available for purchase?
For purchase, well, the demo will be up completely for free, because we want players to be able to play test and play the game, get a snippet of that game. So that's hopefully going up soon. We're in a playtesting stage at the moment, and once that finishes, the game's going to go up after that, just to make sure there's no last kind of bugs that we didn't catch before we upload a build that is broken. So I've been dealing with the past 2 weeks. We've been sending out surveys and people to test out the game, and I've been getting feedback back from them. And I've been using, like, they might come across like, oh, this broke when I did this, or I jumped over this rock and that got me out of bounds, or this character spawned and it completely crashed the game. What's going on? So I had to go in and look, review what they said, see if I can replicate that issue, which can be at times quite tricky. They can be very specific issues. And then when that's all done, patched all up, get the next build ready to go and send that to some new people, and just try and make sure everything is ironed out and there isn't anything that's fundamentally going to break the game and ruin the experience for people. So it's a bit of a back and forth.
What kind of hardware? I mean, the guys are always giving me a hard time because I've stuck to the Apple ecosystem, and they're saying, no, you need to get on Windows. Everybody else is using Windows. You need a more powerful computer than what you're using. What are you using?
I'm currently on my laptop. I have a PC that I use, but I don't really use it as much anymore. It's quite outdated. I built it back in 2018. When I was in school, so all the parts are getting a little bit old, and it will no longer support, or it can't support Windows 11, so I can't update it. And Steam is coming around pretty soon and removing support for Windows 10. So, and I'm not sure when that's going to happen, but that's going to cut out a lot of people's PCs being able to use Steam as a platform, which is quite crazy. But I use a laptop here. It's a studio laptop that I bought for college, and it's still working. And that's been great. So one of the things that's been really handy for us, my friends who I'm working on this with have some higher end PCs. They've got some like 30 series graphics cards, which are pretty damn good. But my laptop has a completely different performance capability to theirs. So when we're testing on their end, it runs great. And then we test on my end, and it's like, oh, this is not working. How do we make this better optimized? So it's actually been very helpful for trying to improve our optimization as much as possible. And we've done a few optimization passes over the past month, which has now allowed us to, my laptop run about 60 frames per second. And on my friend's PC, over like 200 frames a second, just to make sure that we can get everybody, no matter what PC you have, to be able to play this game. And that's been a challenge, but has paid off, having the different PC specs.
So how much time did it take to build the game?
So we started basically straight out of college. When we were in our final year, it was a concept idea. And we were thinking of some ideas and writing some kind of simple design work and stuff like that. But out of college till about now, it's been about a year and a half. We've kind of seen the first year as like a master's year for us, like learning how to build games and use engines, and then go from there. So yeah, it's been a little over a year and a half now at this point. And it's gone through a lot of stages of polish and development to get to where it is now. It's been a lot.
Throwing some parts away, you were saying. That must have been heartbreaking.
Yeah, those were some difficult days. Yeah, that was rough.
Thank you for the question, Paul. Any more questions? Yes, was that Mia, I think? Go ahead.
Yeah. So you said you learned how to code to build this game, but when you had to start, where did you start? Because sometimes I just don't know where to start. So where did you start?
Yeah, I had the exact same issue when I first started out. I was always like Googling, like, how do I learn how to code? How do I learn how to do blueprints? How does any of this work? And then trying it and just not really getting anywhere. And then I decided I took about 2 weeks or so where I sat down and assigned myself little mini tasks. So the first day I'll go, okay, how do I make a box move from A to B, and use some code to just kind of have it like transform across. And I figured that out, and I was like, okay, that's cool. How do I make it teleport now? And then I figured that out, and it worked. And I was like, okay, now I've built a little bit of a library. So then I go, okay, how do I make something, I don't know, grow in scale? And then you kind of work down that path of assigning yourself these little mini tasks, and then you start this building this library of knowledge. And then you start looking at some videos, because I find when you start straight away at videos and you start following different tutorials, they often either speak really quickly or gloss over things without much explanation. And from a new set of eyes, that's extremely frustrating and difficult. And I would find myself on videos like 0.5 speed on YouTube, and like taking screenshots and reading through comments, seeing if anyone had the same problem I had. And ultimately, I decided that it's not going to work, because I was just causing more frustration than it was needed. So I just started assign yourself basically like little bits of homework. Learn how to do this little thing for today, learn how to do this little thing, and work on building that library up. And before you know it, you're going to be well on your way. Yeah.
Very good.
Thank you.
Very good. Thank you for the question, Mia. Next question. Yes, I don't recognize the icon. Is that Zeno? I think. I'm not sure. Go ahead. Go ahead, Zeno.
Do you think you're going to do some other games after this or no?
Yeah, absolutely. One of the biggest games we'd love to do, but we're no way ready for yet, is we'd love to go back and make a game kind of around old Irish mythology, which would be really fun to do, but would require a lot more work and more people. So we're just not within the capability of doing that right now, but we have some ideas on what we'd love to see in like a third person ancient mythology type game. Hence the inspiration of where Fomorian comes from. That's a part of Irish mythology. So we just kind of, that's like an end goal site. But for now, we're basically seeing kind of each game we make as learning how to get to that game. So one day, hopefully.
Thanks for the question, Zeno. So that means you're optimistic about growing this into a profitable business. Address the elephant in the room, yeah?
Absolutely.
Yeah.
That's the hope and dream. So.
Excellent. Great. Next question, please. Oh, they're coming strong and fast. Let's see, who is that? Go ahead, Roberto, I think it was.
What platform would you recommend for like doing a blueprint coding?
So this is all done within Unreal Engine, and that's free to install. If you there's the Epic Game Launcher, which also holds like Fortnite on PC. You can download Unreal Engine through that launcher, and you can get up and running pretty quickly. And you can just use blueprints through there. I could open up the engine and show really quickly how you like set up a blueprint or something if you want. Let me see.
Do you think it's something that we could do as a class, say, next year, or are the hardware requirements very heavy?
No, you can absolutely. Running the engine itself should run on most PCs. I haven't tested anything extremely low end, but I've found that it works pretty well. And it's pretty easy to get up and running and works pretty nicely. There's a bunch of like asset packs as well you can download for free. So if you wanted like to use some nice trees to design some stuff really quickly, you can just kind of download and install and put them in. And you can look up some information sources on how to do some blueprint coding and get that working too. There's so much information and resources on how to learn it that it's very approachable. I
have not heard the word easy and Unreal Engine ever mentioned in the same sentence.
No, it's a headache at times. It absolutely is. But in terms of like navigating around, being able to get into the engine and use it, you can open up pretty well. But it's like easy to use, but like difficult to master.
Yeah. Sure.
Yeah, it takes time.
Okay. Got it. How are we doing, folks? I think I saw 2 hands being raised the last time. Is there another question? Any more questions, folks? Yes. I think that the yellow icon. Who is the yellow icon? Silvia. Go ahead, Silvia.
Why blueprints? Like, what are the advantages?
Well, for me, I find that Blueprints has a quicker entry level to learn. It allows me to kind of iterate on my code very quickly. So if I have issues, I can see very quickly what they are and fix them very quickly and develop code at what I think is a faster rate to make sure that concepts work. So it works very well for indie studios where you need things done efficiently and quickly, and you can get them up and running. It also works better because I come from more of an artist background. So coding to me in like the text format looks very complicated, but for the visual end of things, with Blueprints, I think it's a bit more approachable. So we can get people into the world of coding, I think, easier. Yeah.
Good question, Silvia. I'm going to tie onto that as we spoke about before the call started. Can you tell the students a little bit about what you studied, just briefly, what you studied at university? Yeah.
So I did a degree in animation. So that was basically brought you through how to design characters, 2D and 3D. So whether you're drawing them or you're making them in a software. It showed you how to build a rig. So you're basically putting a skeleton inside your character to allow it to be able to move from when you animate it. So I did like texturing. So you learned how to like give all the stuff its color. A little bit on games, but they didn't touch too much. There was a games course, but I decided to do the animation one. And some other kind of software knowledge, like we used ZBrush, which is digital sculpting. So you'll see all those trees in the bottom left. Those were sculpted with a software called ZBrush. And it's better for making like foliage with a sculpt because it gives that kind of organic look versus modeling, which is more kind of hard surface.
It's really excellent. Yeah, you can tell it's a study to get to this level of expertise. Excellent. Next question. I know we're running a little over time. I hope you're not. Are you in a rush?
No worries. No worries at all.
Thank you very much. That was Cristina raised her hand, I believe.
Yeah, hi. It's about the art and animation, about the college. I wanted to ask for the opinion if you would recommend if someone would want to pursue art and animation, if it's good to go or if it's better to do it. But I want to upgrade my skills, for example.
Yeah, absolutely. I mean, like there is a lot of stuff that you can learn online, but going into a college and learning it there, you get to bounce ideas off other students. You get to learn with other students, helping to problem solve, figure out things together. We often did a lot of group projects where we basically simulated what it would be like to be in a studio. So one person might start off building something and then you'll pass it on to one of your classmates who will do the next step and then the next step for another classmate and so on. So you can kind of get an idea of what it might be like when you're in there, a working kind of scenario. It's also cool. Colleges. Yeah. So it was good fun and it had all the software in there. So a lot of the times in this kind of area, some of the software might be locked by like a payment subscription. The colleges supply all the software generally, so you're able to have access to the industry standard stuff versus some of the more free things. So it's great for learning, for practicing. So it's definitely a good area to get into if that's kind of what you're interested in. Yeah.
Super. That's handy that they gave you all the industry standard software for free.
Yeah, it was great. It was great. Yeah.
That's really cool. So many thanks again, Eoghan, and wishing you tremendous success with ExoDomia. We will definitely make sure that everybody goes into Steam and gives us the thumbs up, and look forward to seeing when it gets published. Wishing you every success, and thank you again so much.
Thank you for having me.
Our time today. Thank you. Thank you so much.
Thank you.
Bye.